All right, you guys, let's start this lesson off. So we're going to be solving a system of equations with 3 or more variables. Basic idea is if you have 3 variables, you need 3 equations or more. If you have 4 variables, you need 4 or more equations. But really, all you're going to do is solve it just like you did with 2 variables, right? We're going to use elimination or we're going to use substitution. So here's a set of steps that we're going to follow. Okay, we just need more equations. So there's going to be like not new steps as in new complexities, but we're just going to have to do elimination more times because we're going to have to eliminate more variables. So the steps to follow, and I've got an example problem right here. The steps to follow is we're going to choose a variable to eliminate. So over here, we could definitely eliminate the z's. Those don't look too bad. We could also eliminate the x's. Those don't look too bad. But we could eliminate the y's without multiplying by anything, just by summing those. So I'm going to do that one. Now, all we do is choose 2 of the equations and eliminate that variable. So we've already chosen we are going to eliminate the y's. All right, so I'm going to call this P1, P2, and P3, just so I can refer to them. So I'm going to choose any 2. I don't want to choose 1 and 3 because then I'd have to change the sign or subtract. So I'm just going to do P1 and P2. Okay, so here's P1 and P2, and I want to eliminate the y. So it's going to look like x minus 3y plus 3z equals -4. And I'm going to add that to 2x plus 3y minus z equals 15. So if we add those together, these cancel, and we get 3x plus 2z equals 11. Okay? Got it. The next step is we choose any other combination of lines. We can't do the first P1 and P2 again because we'd be doing the same thing again, which would be redundant. So we can either combine P1 with P3 or P2 with P3. It doesn't matter what combination you choose. I'm going to do P2 and P3 because the second and third equations just seem like they're going to work out the nicest. But again, it doesn't matter. That's why I say choose any other different combination or pairing. All right, so I'm going to do P2 and P3. We've got P2 is 2x plus 3y minus z equals 15. We've got P3 here is 4x minus 3y minus z equals 19. We sum those together, we get 6x. These cancel, minus 2z equals 34. Okay? And the last step is we solve that just like we would any system of equations. So now that we've narrowed it down, we basically have the first one we worked on, right? This first one and this second one where y has been eliminated. So we just have 3x plus 2z equals 11 and 6x minus 2z equals 34. Okay? Now, if we were to go ahead and solve that, we would get that x is 5, okay, and y is 1, right? So I'm just skipping that part. We've done that in the past. And so if we want to figure out what z is, right? Or we're solving for x and z. I am sorry, let me erase that really quick. We would solve for x and z, and we would get z is -2. Okay, so we just solved a normal 2-variable system of equations and got the x and the z. So then the last step is we just plug it back in. I didn't even write the last step, but step 5, plug it back in to find the last variable. Right? And it doesn't matter which of the first 3 equations we use. Don't use one of your equations from down below. Go back to one of the originals. So let's do x minus 3y. Again, it doesn't matter which one you choose. I'm going to do whatever, 2x plus 3y minus z equals 15. That was the second one. I'll plug in all of our numbers. We get 2 times 5 plus 3y minus -2 equals 15. So this is a 7. This is a plus 2. So that's 3y plus 9 equals 15. 3y equals 6. Y equals 2. And so our final answer, we just write it in alphabetical order, but our last x comma y comma z, right, is equal to, we write the x first, that's 5. We write the y second, that's 2. And we write the z last. So you could write it as a point like this, or you could just write it separately and say y is 2, z is -2, and x is 5. Doesn't matter which way you express that answer, okay? I feel like I made an arithmetic mistake here, but it's okay. Oh, that's where it is. This is a 10. 2 times 5 is 10. Classic. This is a 12. 15 minus 12 is 3. Y is 1. Classic. You got to catch your mistakes. There we go. All right, you guys. So before we go any further and just do some more practice problems, I just want to talk about what is happening here, big picture, right? So, I mean, one big picture is how to do it. You just do it the same as the other system. You just have to do 3 steps, right? You have to eliminate one variable to get one equation, eliminate the same variable to get a second equation, and then step 3 is just solve a 2-variable 2-equation process. The other big picture is when we have 3 variables, what is that, right? So 3 variables in 3D space, as long as we don't have any exponents, like they're all linear, they're all to the 1 power, that's just a plane, right? And so if you have 2 equations with 3 variables, that's saying where do 2 planes intersect? And in general, unless they're parallel, they intersect in a line. And if you add a 3rd equation with 3 variables, you've now got a 3rd plane. And again, unless that plane is parallel to that line, then it's only going to hit that line in a single point. And so this visualization here is showing you what's happening. We're saying where do 3 planes intersect? Unless they are in some form going the same direction, right? Then you're going to get a single point. So here are some possible solutions, right? So on the left, you've got 2 equations with 2 variables. That's 2 lines. They intersect in a point. And then we have 3 planes could intersect at a point or a line, right? That's one example. Or they could be parallel and there's no solution. Or they could have this other form where 2 planes intersect in a line, right? That's what's happening here. These 2 intersect in a line. And then the problem is the 3rd plane and the line are parallel. We're not going to get too in depth with this, but this will fall out to where you will get an impossible situation. You'll get like 3 equals 5, and you'll be like, whoa, the variables canceled out because they were parallel, and I got something that was untrue, 3 equals 5, so there's no solution, okay? All right, let's move on and just solve some problems. I left one more example here just so you have extra practice. Again, I called this P1, P2, and P3 because there's 3 planes. And then I just choose a variable to get rid of. This time, again, I chose let's get rid of the y's. So I got rid of the y's using P1 and P2. I got rid of the y's using P2 and P3. And so now I have a normal old system of 2 variables, 2 equations, okay? I chose the elimination method. You can absolutely use substitution. We got x is 0, and then I went and plugged it back into either of these 2 variable equations and got z is 6. And then I plugged both of those into one of the original 3 variable equations to find that y because I'd canceled out y first. All right, so now let's do a couple of these homework problems, all right? So you are doing the odds, number 1. I'm going to do the evens, so I'm going to do number 2. I'm only assigning 5 of these tonight. If you're watching this a future year, who knows? Maybe I have totally different problems. All right, here we go. System of equations. We've got 3 planes. I'll label them P1, P2, P3. Let's choose something to cancel out. To me, the z's looks easiest, but you could choose any variable. So I'm going to eliminate the z's, okay? I'm going to do, I don't know, the first and the second looks good. I don't even have to change anything. So with P1 and P2, I've got 2x minus y minus z equals 7. I've got 3x plus 5y plus z equals negative 10. Add those together, z's cancel, and I've got 5x plus 4y equals negative 3. All right, so now on the other side, doesn't matter which one. I mean, let's do P1 and P3 this time, just to be different. So P1 and P3, that is 2x minus y minus z equals 7. And then the third one, 4x minus 3y plus 2z equals 4. I like the elimination method, so I'm going to multiply this equation by, I'm not going to multiply that one. We're trying to cancel out z. So I'm going to multiply the first equation by 2. Okay, it's already negative. So writing that down below, that's going to give me 4x minus 2y minus 2z. And don't forget to multiply the other side, 14. All right, so that cancels out the z's when I add them. And I get 8x minus 5y equals 18. All right, so looking at this, neither one is like especially, looking good. I guess I'll just cancel out the y's because they're smaller numbers. So I'm going to go ahead and multiply this whole equation by 5 and this whole equation by 4. And the y's already have opposite signs. So putting these together, I get this is 25x plus 20y equals negative 15. I get 32x minus 20y equals 40 and 32, 72. Okay, that means when we add them together, these cancel. We get 57x equals, well, hot dang, 57. So when we divide by 57 on both sides, we get x is equal to 1. Now we can plug this in anywhere, but it's got to be to a 2-variable equation. So I'm going to go ahead and plug it in over here for no arbitrary reason. I'm going to get 5 times 1 plus 4y equals negative 3. So 5 plus 4y equals negative 3. That's, 4y equals, we subtract the 5, so we get negative 8. We divide, and we get y equals negative 2. Okay, and finally, we got to plug both of those in somewhere. So I'm going to take both of these, and let's say the first one has the smallest numbers. So I'm going to plug both of them in to the first equation over here. All right, so I got 2 times x minus y minus z equals 7. So that's 2 plus 2 minus z. I always put that extra slash in my z so there's no miscommunications. So that's 4 minus z equals 7. That's negative z equals 3, or z equals negative 3. Again, you could leave them all three separate or in alphabetical order. X comma y comma z is the solution to the system of equations. So that's the one point where all three planes intersect. All right, let's go to one where things are missing. What? That's crazy. You can't do that. Nah, just kidding. That's fine. They actually just did one step for you. So really, they've already eliminated a variable in one of the equations. So let's do number 10 here and figure out, I don't know, what are we going to cancel out? Doesn't matter to me. I don't know. I don't see any one that looks any easier than the others. So let's just cancel out the x's for no reason. Okay, whoops. So I'm going to cancel these out using P1 and P3. And then notice P2 has no x's. So what? We're already done with the step. Okay, so let's do it. So I'm going to multiply this one by, let's say this is the negative. So I'm going to do negative 2. And I'm going to multiply the top one by positive 5. And so I get P1 and P3 is times 5. So 10x minus 15y equals 15. And the bottom one is negative 10x plus nope, minus, but plus a negative 14y equals positive 30. So when I sum these together, oh, I wrote y, that's z, sorry, my bad. Look at all these mistakes. When I add it together, we get minus 15y minus 14z equals 45. Okay, and we just have an equation already done for us that is 4y plus 2z equals negative 6. That already has the x's eliminated, so it saved us a step. And now we're going to put these together. So if I want to do elimination here, I'm going to do the z's because I only have to multiply one equation. If I multiply this one by just 7, I can eliminate it. So the first equation doesn't change, okay? That's minus 15y minus 14z equals 45. And this one does change. We get 28y plus 14z equals negative 42. So when these cancel, shoop, we get 13y equals 3. Okay, and then I feel like I made a mistake here. Let me double check my work really quick. So I'm gonna multiply by 5. That's 10 minus 15. Oh, 25. Look at that mistake. So over here I get a 55. And then down here, 55 minus that is 13. There we go. I knew it worked out evenly in this one. Okay, we will get some sloppy fractions later. So we get y is 1. Okay, again, we plug that in. I'm going to plug it into the right over there. So I'm going to get 4 times 1 plus 2z equals negative 6. I'm going to subtract the 4. 2z equals negative 10. So z equals negative 5. Then I have to plug both in to one of the original equations. Notice that both the first and third only have 2 variables. So I don't know, I'm just going to do the first one. So 2x minus 3y, so 2x minus 3 times 1 equals, I believe it was positive 5, yep. And so I get, adding the 3, 2x equals 8, so x equals 4. Again, you can leave it like that, or in alphabetical order. The answer is 4, 1, negative 5. Shebang. All right, let's make it harder. What if we have crazy fractions, right? So if we have a system where there's numbers on the bottom, we could just multiply the whole thing by the common denominator. So if we were to combine all those fractions, the smallest, easiest common denominator is a 12. You could do any multiple of 12, 24, 36, 144. But if we multiply every single one by 12, right, the whole equation, all those fractions go away. Easy. Uh-oh. But if there's variables in the bottom, if I were to multiply the whole thing by x, y, z, I get 4yz. What? Minus 2xz? That's not helpful. We don't want this crazy polynomial with variables everywhere. So the trick when you have the variables on bottom, or some on the bottom, some on top, it doesn't matter, is instead we think of this like 4 times 1 over x minus 2, 1 over y, plus 6, 1 over z, okay, equals, I need to change my pen size. That's as small as it goes, equals negative 5. And then you're solving for 1 over x, 1 over y, 1 over z. You could think of like substituting these. For example, I could be like, okay, so we're going to call 1 over x w. We're going to call 1 over y, I don't know, v, x, y, z, v. Yeah, let's go v. And we're going to do 1 over z is, I don't know, s, whatever. No, s kind of looks like a number. Let's do p, okay? So then you could say, well, I'm really solving a system of equations where it's 4w minus 2v minus 6p equals negative 5. The next thing is negative 3w minus 5v plus 4p equals negative 3. 2w plus 7v, whoops, that's a v, minus 10p equals 2. So if we set it up like that, we just have a normal old system of equations. And then at the very end, if you get, for example, W is 3, well, we know that that means 1 over X equals 3. And so we just flip both sides over and we go, oh, that means X is 1/3, right? So that's the easy way to do it when all 3 variables on the bottom. You really just solve for the reciprocal, treat it as though 1 over X was the variable. And then at the very end, you just get whatever your answer is, you flip it over. So that's the easy way to do a problem like that, if you were to encounter one. Okay, lastly, let's do a crazy freaking word problem, okay? So we've got a road from tedium to ennui, right? Get it, like boredom to boredom, okay? Uphill for 5 miles. So let's draw a little map, okay? We go uphill for 5 miles, level for 4 miles, then downhill for 6 miles, okay? And that's going from T to E, all right? And it says, so we already got the first part, so I'm just gonna highlight that. Okay, we got this, great, okay? And it says at the end, what are his rates walking uphill, downhill, and on level ground, or if they remain constant? Okay, so let's label and let's call this rate, whoops, that's a highlighter, not a pen. Let's call this rate X, this rate Y, and this rate Z. So the uphill speed is X, the flat speed is Y, and the downhill speed is Z. Okay, so X is uphill, Y is flat ground, and these are all rates, okay, and Z is downhill, okay? And then finally, if we're talking about time and speed, I'm guessing the formula we're gonna use here is distance equals rate times time, okay? So I'm guessing that's the formula we're gonna use. And then if we read this, it's saying back again in time, back again in time, back again in time. So it looks like our equations are going to be dealing with time. So I'm going to rearrange this and go time equals, we divide both sides by rate, and we get distance over rate. Okay, so that seems to be what we're going to do here. All right, so let's go over here and see what we got. So erasing this, first one. We've got John Garfinkel walks from ennui to tedium. So he's going backwards in 4 hours. So in this case, since we're going backwards on trip 1, this is trip 1, okay? So first we go 6 miles uphill, then we go 4 flat, okay? And then we go 5 downhill because we're going backwards. And that took 4 hours, all right? So I'm just writing this out in like layman's terms, okay? The next one, okay, so let's get our highlighter and say we got this, walks from ennui to tedium in 4 hours. He later walks halfway there. So keep in mind, halfway is in miles distance. So total, the distance is 15. So halfway, I'm gonna erase this really quick. So I'm gonna erase this, that was trip 1. Okay, so now we gotta figure out our next move here. So we're walking halfway from T to E and then back. So he's going 7.5 over and 7.5 back. All right, so let's write that out. So that's trip 1, let's do trip 2. So he's going 5 up, and then after 5, we're going 2.5 flat. Then we're turning around to doing another 2.5 flat back, okay? And then after that, we're doing 5 down. All right, and that was 3 hours, 55 minutes. All right, and then lastly, let's highlight that. All right, lastly, still later, he walks from T to E, and that's how much time. Okay, T to E is our original, so that's 5 up plus 4 flat plus 6 down. And that's equal to 3 hours, 52 minutes. Okay, woo, looking good. All right, so now all we gotta do is turn these into equations. So as is, our uphill speed is X. So rewriting these, our system of equations is, whoops, that's the highlighter. Go back to pen here. We got 6X plus, and notice though, we got 6 is miles, that's our distance, and the rate is X, so shoot dang, we're gonna have the formula for our time actually be 6 over x plus 4 over y plus 5 over z equals, oh shoot, that's just like this problem. And so really what we want to do is deal with 1 over so we don't have to deal with any fractions in the middle of the problem. So I'm actually going to change this, and we're going to say, let's scratch our old plan, okay? X isn't the uphill speed. X is 1 over the uphill speed. This is 1 over the flat speed, and this is 1 over the downhill speed. So now we can write, re-erasing this, we're going to say we don't want any variables on the bottom. We're going to say instead it's 6x plus 4y plus 5z equals 4. We're going to say 5x plus 2.5 and 2.5 is 5y on flat ground plus 5z equals, oh shoot, 3 hours and 4. Let's change, instead of hours, let's deal with minutes. That's going to be a lot easier. So now we're in minutes. So we've got, this is 4 hours, so 240 minutes. 355, so that's 235 minutes. And lastly, we got 5x plus 4y plus 6z equals 232. Boom. And in all of these cases, we have x, y, and z are equal to 1 over the uphill rate. And the units we are using minutes and we are using miles. Okay, so just keep all of that in mind. So at the end, we can revert it. All right, so you could stop here and just go ahead and start your homework. I'm gonna solve this, okay? I'll talk it through. It's gonna be big numbers. So we got P1, we got P2, we got P3. No one of the variables looks like especially nice, so I'm just gonna cancel out the x's. First, I'll do the easy one. P2 and P3 is nice. If I just multiply either one by a negative, I'll do the second one by a -1. I get 5x plus 5y plus 5z equals 235, and on bottom minus 5x minus 4y minus 6z equals -232. If we add those together, we get y minus z equals 3. All right, and so now for the next one, it's just gonna be big and ugly. Like either way, I'm gonna have to multiply. So for the second one, I'm gonna multiply the bottom one by -6 and the top one by +5. So I am with P1 and P3. The equation is 30x plus 20y plus 25z equals 1,200. Well, that wasn't so bad. And then we got -30x minus 24y minus 36z equals, I'm going to use a calculator for that one. Okay, so 232 times 6, that's 1392. And that's a negative, right? Negative, yes, it's 232, -1392. All right, so now we add those. Shoop. These cancel. We get -4y minus 11z equals -192. Okay, we can easily cancel with either of these. So I am going to multiply all of this by 4. Okay, so our new system down below is 4y minus 4z equals 12 and -4y minus 11z equals -192. That's going to cancel. We get -15z equals -180. So that means z equals, is that 612? I don't remember. 180 divided by 15. Yeah, that's 12. Okay. So z is 12. Let's plug that back into the easiest one. And we get y minus 12 equals 3. So y is 15. Okay. And then over on the other side, we got to plug into some equation. I'm just going to do the first one arbitrarily. So 6x plus 415 plus 5 times 12 equals 240. So we get 6x plus 60 plus 60 equals 240. So 6x equals 120. So x equals 20. Okay, so remember, x was 1 over the uphill rate. So this means, whoops, I'm going to just erase what I just wrote. I'm going to say the downhill speed is equal to 1 over 20. And again, we are doing the units for that 1 over 20 is the rate is how many, how many miles per minute. Maybe that's not a useful unit. So if we want to turn that into miles per hour, how do we do that? So if you guys haven't done unit conversions before, if we want to turn miles per minute into something else, we just go times, and we have to multiply by something that's equivalent to 1. And so we could say, well, I want to cancel out the minutes, okay? So I'm going to put minutes on top. And so I want to get miles per hour, so I want hours on bottom. So the minutes will cancel, and we have hours. So how many minutes are equal to how many hours, so that I'm multiplying by 1 and I'm not changing the value? Well, I know 60 minutes is equal to 1 hour. So if we just multiply by 60, that's going to convert our miles per minute into miles per hour. So our downhill speed is this times, I'm going to do it in pink here, times 60. And so we get our downhill speed is 3 miles per hour. Ooh, okay, so that's our down. All right, we'll do the same thing for the others. So we get z, which was our, in order, that was our downhill. So we got our downhill speed is equal to 1 over 12. That's in miles per minute. And then we times by 60. Okay, so our downhill speed is equal to 5 miles per hour. And finally over here, we've got our flat, just checking why is our flat, yep. So we've got our flat ground speed is equal to 1 over 15. Again, that's miles per minute. So we're gonna multiply by 60 to convert it. And we get our flat ground speed is equal to 4 miles per hour. What the heck, that's so nice. Okay, 3, 4, 5, it worked out so pretty. All right, guys, that's it for the video.